A change of venue for today's video because the victim of today's video is far too big to sit on my workbench, my normal workbench. I'm out in the garage and my microwave has died. You see that scorch mark there? That is right where the magnetron is. So I am going to be tearing this guy apart and seeing exactly what failed in there. My guess is that the magnetron has a short circuit and dragged the power supply down, but we'll have to see. I'll just get in a little bit closer and power the thing up, and hopefully you can hear this when it runs. That's normal. Did you hear that? That to me is the sound of the transformer really struggling because it's got far too much current being drawn through it, which, as I said, is a pretty good symptom of the magnetron being shorted. But let's tear it apart and see if we can figure that out. Just a handful of screws on the back of here to open it up. Oh, that one's a security screw. Okay. What we got here? That'll do nicely. It is, in fact, a security Torx with a little nubbin up the middle there. Fortunately, pretty much every screwdriver set these days has security bits in them, so they're not all that tamper-proof and secure. That makes quick work of it. So here's the fun part. The magnetron itself, which generates the high-frequency, high-power microwave radiation, is inside here, and it's got a little waveguide there going inside into the cooking cavity. Here is all the controls over on this side. Power supply down there. What do we got up here? Input filtering. Let's take a closer look at that. Anyway, here we go. We have a fuse. We have an inductor. Is that a common mode choke? Yes, it is. So both lines go through there on the same ferrite core. Okay. We have a couple of MOVs here and a couple of good-sized capacitors, 2.2 microfarad. So that is just input filtering. Here's the live and neutral coming in. There's the neutral going out to the circuit, and here is the live going out. And that live goes out through a little thermal cutout over there and back into the circuit over here. On top of the magnetron, we've got what looks like another thermal cutout. Oh no, it's the light bulb. Okay. That would have been a pain in the ass to change. Down in here, we have a micro switch, which is attached to the door latching mechanism. You can see moving there. That is a useful piece of salvage. Obviously, a lot of what's in here is not going to be reusable, but some stuff like that, that's just a common little switch. That's definitely reusable. What else do we have? Oh, another little micro switch also on that door latch. Wow. They really, really don't want this thing to run while the door's open. Although one of them is probably, one of them is for the light. Okay, that makes more sense. Oh, and there's a third micro switch down here. These are all rated at 16 amp, 250 volts, so those are definitely useful salvage. So initially, I thought this was a ground, but I don't think it is. I think, judging by that insulated jacketing there, I think that is actually a thermocouple. It's just bonded to the outside of the magnetron's waveguide. That goes on to this connector here that was on the controller board. I'll definitely add that to my power salvage. I'll take that indoors and just test it and see if it is in fact a thermocouple later. Those connectors really don't want to come off the board. There we go. There is the main controller board. We have a transformer power supply. We have bridge rectifier there on the low voltage side, smoothing capacitor, transistor there. There is the ribbon cable that goes to the display on the front. There's a small relay. There's a large relay. There's a little buzzer beeper. Two optional components that don't exist on this thing. And on the back side, only one surface mount component with its part number scrubbed off, of course. But let's carry on from here for now. So here is a little cooling fan back there, which is in parallel with a couple of other wires that disappear down here and underneath. So I'm going to guess that that's going to the little motor underneath the bottom that turns the turntable and rotates your food while it's cooking. Fairly low current wiring on that too. Oh, okay. So it's got some little clips on the bottom here and just this little tab that kind of locks it in like that. And then that power supply can just lift right out of there. Cool. I think I might take that inside to look at it closer too, because that will fit on my workbench. But then that just leaves the magnetron itself remaining. Let's see if we can get it out of its waveguides and out of its mounting here. I don't know if there'll be all that much interesting to see, but we'll check anyway, because I'm curious. So that is just an air duct. Air comes, I guess, through from the fan, through fins on the back here, and into the cavity. And then we've got 4 more screws, 2 there and 2 over here. There is the magnetron tube. So we have some big honking heatsink fins there. There is, oh my goodness. So this bit here is essentially the antenna that is radiating the microwave energy into the cavity. And as you can see, it's pretty badly burned up. That bit there is ceramic. This looks like some copper mesh screening just to keep everything contained where it's supposed to be. It's essentially electrically ground. It's just acting as shielding. And then there's 2 inputs from the power supply. And that's about it, other than the high voltage warning, of course. All that's left on the carcass is to take a look behind this little control panel here. I'm just going to pull out a few more screws, which my shoulder is going to be in the way of you, so I'll just do that and come right back here. All right, here we are back in more familiar surroundings. Let's just take a closer look at some of these components. I got the fan out of there. It's just a basic AC fan. That could be useful for, I don't know, ventilating the garage or something. Or maybe nothing, who knows. Looking closer at this power filtering board, the fuse is a 20 amp fuse. Everything else is how I identified it out there, except for these are not MOVs. These are in fact capacitors, which are just shunting any high frequency spikes out to protect the circuitry. These micro switches, they are all, oh no, these ones are 15 amps, or this one's 15 amp rated. These 2 are 16 amp rated, so there'll be nice additions to my stockpile of bits and pieces. This little guy here is in fact a thermocouple, but it's not a K-type. I've got it connected to the thermocouple input of this meter, and as you can see, it's showing 235 Celsius or 450 some Fahrenheit. And then when I heat it up, it actually drops. but it is definitely a thermocouple, just not a type that I'm familiar with. The magnetron, I tried to pry it open, but this back can is actually welded or spot welded on, so we're not getting in there. We'll have to look at it a different way, but I don't think there's much to see inside there anyway. There's some tuned cavity stuff, a couple of electrodes, some magnets, hence the name magnetron, and that's about it. Let me just show you the Wikipedia article. So there is what it's supposed to look like when the front of it's not burned off. It's pretty obvious to see the contrast between that one and the one that I've got sitting here. I'll link you to this article because there's a lot going on here and it's some very deep science. But basically, the high voltage comes in, heats up the anode or the cathode in the middle, and then that starts emitting electrons. Those electrons go or bounce into these little resonating cavities, which are specific size, which generate a specific wavelength as they bounce around and resonate in there. And then they're focused and come out the little output coupling antenna and gets sent out. That's the short version. Like I said, I will link to this article from Wikipedia, which goes into much more detail if you care to know. And then here is actually the main control board. I thought this was the main control board, but it's not. It's just an interface board. It has the two relays that control the magnetron power supply and everything else. It has, as I said earlier, the diodes and all transformer-based power supply there. It has the connector that goes out to the main control board. On the back, there's a little tiny chip here. Under graduating conditions, I thought it didn't have a number on it, but it clearly does. AS358M. 358, if I'm not mistaken, is an op-amp. Yep, that's exactly what it is. A dual op-amp. So op-amp makes a certain amount of sense. I guess it's probably amplifying that thermocouple. That would be my guess anyway. Regardless, we have a flat flex ribbon cable coming off this board going down to the main control board, which is behind the control panel. We have this little knob here. That's a rotary encoder. That is for setting your time. And we have some switches here, 9, 10, 11, 12, 13, 14 switches. And we have a 4-digit 7-segment LED with a few other digits for good measure. Just little display bits and whatnot. Anyway, in the back of here, we have the little control chip, which is driving the LED, taking in all those buttons. It's running a real-time clock. It is running a timer. It has some programs, so you've just got like a one-button push for popcorn or potatoes or boiling water or whatever. A bunch of little programs that I personally never understood, but they're there. There are some numbers on there. I'm going to try and read them a little bit better and see if I can look them up. But I'm going to guess that it is an application-specific microcontroller just designed by Panasonic for these Panasonic branded microwaves. So that's the number as far as I can tell, but this is about the best hit I could find for it, which is completely useless, but apparently they go for $20 theoretically from this random Asian seller who, yeah, original physical shooting can be shot directly. I don't know what that means. And then that leaves the power supply. So normally when you see people talking about microwave oven power supplies, they are one big honking transformer that just generates high voltage to drive the magnetron. Not so here. This is what's called an inverter microwave oven, and this power supply here is using high frequency. It is generating high frequency, amplifying it with these, with that chip over there. That is most likely a bridge rectifier. In as much as it's got 4 pins and it says dB right there, so that will be a bridge rectifier that knocks the line voltage down to DC. And then this chip on the back of here, whose number I also tried to look up and couldn't find, feel free to test your Googling, N7054A. But I'm going to guess that it is the power supply control chip, because what else would it be? It will be generating the higher frequency for the transformer and probably monitoring currents and voltages and stuff like that. And then that chopped up higher frequency will be being switched through this high power device. So the pins of it down there are labeled C, E, and G. C and D, I would expect a collector and emitter of a BJT type transistor, but G, that's not expected. And unfortunately, I cannot read the part number on it because this transformer's in the way. I would have expected it to be a MOSFET handling that kind of power, but a BJT can do it as well, just slightly slower, and slightly less efficient, but that may not be an issue in here. Regardless, then we have some inductors and capacitors over here, and we have the main event, the big transformer. So we have one big heavy winding. All these strands here are a single conductor, or considered electrically a single conductor. So there's only about half a dozen, maybe 8 or 10 turns on that side. And then over here on the high voltage, lower amperage side, we have 2 windings in series, and these 3 windings are all on that same ferrite core, so they're all magnetically coupled together. So these windings here, I'm guessing they're separated just to keep them from sparking over as the voltage climbs. Anyway, their signal comes out through these devices, which look like they should be diodes, but they don't measure as diodes. Unless, maybe, they're probably high voltage diodes, in which case my meter doesn't supply enough voltage to make them break over. But anyways, that's creating DC, which then comes out here and goes to our magnetron. We have this interesting little high voltage resistor down here. It measures about 70 meg, but what makes it a high voltage resistor is just the distance between the 2 contacts on it, just so that things can't jump over as easily. And then down here we have these 2 capacitors, 882J and 562J, which are up in the, was that 8200 picofarads and 5600 picofarads? I think that's right, at 3 kilovolts each. And on the back we can see some pretty serious track action going on. There's all the control side down here, and then there is the drive transistor. Here is the incoming bridge rectifier, filter. Where's the voltage coming in? Over there. So there's the AC 120 volts coming in. All right, a couple of diodes there. And then, oh, this is interesting. This whole cluster of resistors here looks like it's actually acting just like one big resistor. Oh no, maybe a couple of resistors. These ones are all in series. These guys are in parallel. Interesting. So I'm assuming that's just to spread the dissipation out a little bit. Although why they wouldn't use a big honking resistor like that to do that, I don't know. This is a 7 watt resistor, and see if we can measure it in circuit. And is that 1.9K? 2K, something like that? Yeah, probably 2K 7 watt. All right. Regardless, this power supply is not the type that you can cut the transformer out and modify it and turn it into a welder, because this thing is designed to run at high frequency, not at the 50 or 60 hertz line voltage. Still, an interesting little power supply nonetheless. Probably a few components that I could grab out of there. Certainly the heat sink, that big bridge rectifier. I doubt that transformer is going to be useful for anything except for scrap copper. But I wasn't really expecting to get a lot of salvage value out of this anyway. My entire point was to figure out why the thing died and just generally figure out how it works. And of course, the why it died is pretty obvious. This guy just got eroded away over time. And I don't know if that happened all at once or if it just, like I said, happened over time. I didn't notice the microwave getting weak as time went on, but maybe it was slowly and I just didn't notice. I don't know. Anyway, that was fun. I hope you saw something that you hadn't seen before. I certainly did. Thanks for watching. Questions and comments down below as usual. I'll talk to you later.